The video demonstrates serial communication through 8051. When we are dealing with the hardware part of serial communication through 8051, make sure that the board is always in program mode, not in execute mode. So, first of all, we go on and switch from execute mode to program mode. Next, this will be the code for serial communication in which 8051 will be constantly transmitting the character A to our PC, and we can view the receiving part on our PC through any virtual terminal. The code will be explained in the later part of the video during Proteus simulation. Now we go ahead to dump this code on the board. And so we use a software from Atmel which is Flip. In the Flip, first of all go to choose your board as 89C51ED2. Press OK. Next we set communication using RS232. We give our COM board as COM11 and we specify our baud rate as 9600. Then we connect our board. After connecting, we load the hex file. So we open the serial communication hex file and then we run it. It will take a few seconds to complete the process. After it is completed, we go on to change this hex numbers as FFFF0E. Then we click on Start Application. Thus our code is dumped into the 8051 board and we switch back to execution mode. To view the receiving part on our PC, we can use any virtual terminal. So in our case, we use PuTTY. In the PuTTY configuration, first of all select serial and then give the correct COM port. After that, make sure that the speed is 9600 and open the terminal. So you can see that constantly A is received on the terminal.
Hey guys, by this point in the video, you would have been familiar with the software KEIL 8051 and serial communication in 8051. So here is a bit different code written by me than the previously shown on hardware. The difference is that in this code, we will transmit and receive and also display it on LCD. So whatever things you type on your serial or virtual terminal, you will be transmitting it to your 8051, which will be further displayed on the LCD, and further you will be receiving back on the serial terminal the same character. So here you can see the basic commands of an LCD to initialize the LCD, to point it to the first character, and then clearing the LCD, cursor blinking, and for every character you print shift right, the basic commands that you use for LCD. Here comes the serial communication part. For serial communication, you use this register SCON, which is the most important register in serial communication. Here is the SCON register. The SCON register is an 8-bit special function register. To basically set it to UART communication, you set the bits SM00 and SM11, basically mode 1, and you also enable your receive. So, and for the rest of the bits are currently not used in the program. So if you have any other queries regarding the bits, you can Google and Wikipedia and any other informative websites you want. So in the program, further you use your timer to set the baud rate. So here you use your timer 1 to set the baud rate. Tmod is to specify that you will be using your timer 1 and the 8-bit auto reload mode. So you set the TH1 as FTH to set the baud rate as 9600. Further, you can also communicate at different baud rates from the following table as shown here. So And let's further proceed. TR1 is just to start the timer. Basically, you start the timer to generate baud rate. Then your RI is the flag which you use to poll. Whenever your RI sets to 1, basically you have received your character from the serial terminal. So here whenever it sets to 1, you receive a character, you clear RI, and then further you copy the same character from your SBUF register, which is like a serial buffer register, to your accumulator. Further, the code is to transmit back again to the serial terminal. So further, whatever character was there in your accumulator, you transfer it back to serial buffer and then poll for TI. TI is also a flag which indicates the end of transmission. I mean, it will become 1 as soon as your transmission has been completed. So as soon as your transmission is completed, you poll till then to TI, then you clear TI and then move the same character to your LCD. So here are the basic LCD commands as we explained you in the previous. For any other queries, please mail us. Let's check whether the code is running or not. So save, zero warnings, build and compile, 0 warnings, and here you can see the code is running. So let's see the same thing on Proteus. So here I've used a virtual terminal. You can find the virtual terminal over here, virtual terminal, and LCD, as you know, you can find it in parts, LCD. Here we have used a 16x2 alphanumeric LCD. Or yeah, 8051 is the common as in all videos, so I guess I do not have to show you that. So let's see whether and yeah, make sure that your correct hex file has been uploaded to the 8051 chip. So here is the serial.hex file I'm uploading over here. Okay, so let's see if the program works. To view the serial terminal, you can click over here. So let's transmit characters A. As you can see, the character A is transmitted over here, and you can see it on the LCD, which is further then again transmitted back to the virtual terminal. The shift in characters is because of the issue in Proteus. If you run the same code on hardware, you won't face any problems. So yeah, the code is running. As you can see, I type more characters and I get more characters back on the virtual terminal, so you can communicate with your 8051 successfully. I hope you liked the video. For more informative videos, you can subscribe to our channel, and please like our video if you found it informative, and comment if you have any issues, and mail us on the mail ID mentioned in the description. Thank you.